where they are in relation to the thickness. Now we're down to test section 01A320, which is the slurry seal section here. Show you a sign up here which shows the main thing affecting traffic back behind us, which is that bridge back there, which is US 231 going off north to Wetumpka, Alabama, north of Montgomery. Picking up again, moving on down, just starting from the beginning of the test section, we see more of the same. We've got some flushing in the center of the lane. I don't know whether I should characterize that as bleeding or not officially. I'll do something. Worry about it later on, because that's consistent up and down the test section. But generally our distresses again are moderate and low severity longitudinal cracking and low severity raveling, which is most profound in the inside wheel path. Really in the 2 feet on the inner edge of the lane there. Up on station 1, crack beyond it. Just about any of the cracks that we've seen out here are of a width that they are sealable. One thing that'll be interesting to watch throughout time with this on this particular test section is how well the slurry, one effect it should have is to obviously reduce the raveling that we have out here. Interesting to compare, that may be something in a section like this where that may wind up being as effective a treatment as any. As you start picking up raveling, you start having more intrusion of water, which causes more and more problems as you go. Section back over there is approaching a moderate severity of raveling. It's lost quite a bit of aggregate over there. It's about as much as I've seen so far, or that I've noticed. It's probably a better term. Got some more on up here ahead, and you can see where we started a new load on a laydown machine here, and where raveling appears to pick up in the inside wheel path there. Yeah, that's pretty bad in there. We also got a rather wide crack right in there. It's around station 4. Walk over here and focus in a little bit more on it. See how this is raveled pretty badly in here, and it's even worse in the other lane. It's going to be real interesting to see how well the slurry stands up to this texture of the surface. Interesting to see if the densities vary going across. One wonders how well that was compacted right there. Well, now we're at the end of that test section, and they're out here coring another hole, so we'll walk up over there and inspect it. On this core, which is right at the switch over between the slurry seal and the crack seal section, we have about 9 7/8 inches total of asphalt concrete. We should be having around 10 inches or so, and that's what we seem to be getting consistently through here. Again, here in Alabama, they specify by the pounds per square yard rather than by the thickness. And so any thickness that we have is generally going to be an estimate anyway. But again, we've got about the same amount of the wearing layer there, just slightly less than an inch, about 15/16 of an inch. And then the remainder of it being the binder layer and then the base layer, which are, in terms of gradation, essentially the same mix. Those are the maximum size of aggregate and so on. The mix design is very similar to those types of mixes in Alabama. A little bit closer inspection, you can perhaps get a better view of the quartz and silicious aggregate used here. It's real interesting to see how well some of these